Hey guys, we're going to go through, this is lesson 9-1 day 2, page 3. So you should have taken, depending on your class, these notes. If not, go ahead and just kind of zoom in. So we talked today about a type 1 error. That's when the mold hypothesis is true, but accidentally we made the wrong choice. And it's actually not by accident. This is actually going to happen by chance alpha % of the time. So most of the time they just set alpha at 5. So 5% of the time, if we make a test, just like back in my weather example, if I do a confidence interval of 95%, 5% of the time I know I'm going to be wrong. So that's called a type 1 error. Okay, well, what's a type 2 error? That's when you walk through door number 2. So what really happens and what's the consequence? Well, that's when your little sneaky suspicion was right. The alternate hypothesis was true, but we made the wrong decision. We just ended up by pure chance to not get sufficient evidence when we should have. So if you want to make a little table here, sometimes it helps people sort this out. So what is a type 1 error? That's when you walk through door number 1 and you said that the null hypothesis, that you said, yes, the null hypothesis is true, but that's an error. You screwed it up. You were wrong, which is why I crossed it out. What is a type 2 error? That's when you actually commit an error because you said, yes, the alternate hypothesis was true, when in fact, oops, I got it wrong. Okay? So the null hypothesis is true, but we got it wrong. The alternate hypothesis is true, but we got it wrong. Okay, so let's work through our choices here. A manager of a fast food restaurant chain wants to reduce the proportion of drive-through customers who have to wait longer than 2 minutes. Wow, this sounds really useful in the real world. I don't know about you, but I don't like to wait longer than 2 minutes. Based on this store record, the proportion of customers that waited longer than 2 minutes was that. So to reduce this proportion, the manager assigns an additional amount of employees to the drive-through window. During the next month, the manager collects a random sample of 250 and finds that the sample proportion is this. So the manager then performs a test. So let's think about, what does this mean? Okay, so the accepted truth is that the proportion is 0.63. So out of 100 cars, 63 should have to wait longer than 2 minutes. We have evidence that it's something shorter than that, okay? Right, because that's something less than that. Okay, so let's piece this together. What would a type 1 error look like? That's what the next question says. Well, again, using our script, a type 1 error is when the null hypothesis is true, but we make the wrong decision. So we have to say, well, type 1 error would mean it's true. 63% of customers wait longer than 2 minutes, but the manager thinks it's less. Okay? We made the wrong decision. What would a type 2 error look like? Well, that would mean H sub A is true. So we'd say it is less than 6.3, but the manager thinks it's actually H sub O, that that 63% would do the waiting. Okay? So could you have written different things than this? Absolutely. So don't erase everything you wrote. But again, we're trying to practice writing generically. Type 1 error is when the null is true, but we got it wrong. And a type 2 error is when H sub A is true, but we got it wrong. Okay, so let's keep going. It says, what type of error is more serious in this case? Justify. So let's think about this for a minute. These take a little thinking. a type 1 error would be pretty bad because the manager believes that the extra employee reduces the proportion of customers who wait, but it doesn't. So by adding the employee, they're thinking, right? The hunch was right, but we got evidence that it did decrease. So because the manager believes the ex-employee reduces the proportion of customers who wait, but it really doesn't. We got it wrong. H sub O is true, but we got it wrong. It truly is this proportion, not less than that proportion. Okay, so based on our question from 2, do you agree with the customer's choice of setting alpha at 0.10? Let's think about this for a minute. This takes quite a bit of thinking. No, if the null is true, if the null really is true, then setting alpha at a higher level will result in a type 1 error 10% of the time. So when you set it at you know that if you set alpha at 0.05, 5% of the time you will get it wrong. If you increase your alpha, then now you're getting it wrong by pure chance 10% of the time. They should actually use a smaller alpha, okay? If you're trying to detect, you want to make alpha smaller. Okay, so what does it mean in 4? The p-value of the manager was this. Interesting. Let's interpret the p. So we practiced that today. This would be one way to interpret the p. Assuming the true proportion of customers who have to wait really is 0.65, so that's our script. If H sub O is true, then our p-value is the probability of getting at least a sample portion or less by chance. Okay? Sounds good? Thanks for joining me, guys. See you next time.